Okay guys, this video right here, this is going to be one of the final videos on how to build a GPS guided robot. In this one we're just going to be covering the Arduino code. So I'll be kind of explaining the code for you. Now keep in mind, some of this code I haven't read or touched in probably 6 months, so some of it's kind of old stuff to me, and I really haven't seen it, haven't had to deal with some of it, so my memory might not have been in the world on some of it, so I might be skipping around a little bit. But uh, first and foremost, go over the main thing right here is these libraries, which you'll need to, these include statements here. Most of it probably already have, you don't have to worry about, but the motor control library right here, this is the one that for the L293D motor control shield. This is one you'll have to go to Adafruit's website and download this if you haven't already got it. Of course, if you already deal with the motor control shield, you've probably already, of course, already got this one. But anyway, you'll need to go to their website and download this library. So that's one library that you probably have to download. You probably don't have that one. The wire, this is for the I2C compass. This one I believe is built into the Arduino IDE, so you probably shouldn't have to worry about going and downloading this, or this one right here. Probably won't have to worry about downloading that one. This one we covered in I think it was 2 videos ago about the compass. I showed you where to go to download this library, so you'll definitely need, if you haven't already done so, you'll definitely need to download this library. The servo library, I'm pretty sure, is already included in the IDE, so I don't think you'll have to download that. But the only reason why this is even in here is for the little servo motor that I kind of used in one of the videos, kind of for the metal detector arm, and of course you can also use it for sweeping the ping sensor, the distance sensor, back and forth to check for any obstacles. You could use it for that, although I haven't really done it for that. But anyway, that's the code for sweeping the servo just back and forth. So that's the only reason why you would need that. You could, opt not even have that in there if you wanted to take it out of the code and erase that portion of the code. Software serial, really I don't think you're going to need this at all. I mean, you could probably just comment this out if you wanted to. I just included it in there at one point because I was actually using software serial for some other stuff, but most everything as far as our serial communications, we're using hardware serial, which is much faster. And so yeah, I really don't think you even need software serial. But you might leave it in there because you might decide to make some changes to the code and actually use software serial for something. Although I would tell you, definitely don't use it for the GPS, because the hardware serial is so much faster than software serial, and your GPS needs to update as quickly as possible. So and then this one, Tiny GPS++, that is a very important library. You'll need to go to this website right here and download the Tiny GPS library and install it into your Arduino IDE. And this is really what makes the world go around right here. This is very critical for this the GPS guided robot. If it hadn't been for this guy developing this library, I probably would not have been able to accomplish this task. So my thanks go to him for creating this. And there's a lot of information that you can get off of one of these GPS modules. I mean, not only you're talking about getting your, actual location, and everything, but you can get today's date, you can get the time on there, you can get your speed, how fast you're going, your altitude, the number of satellites that you're locked onto, and just all sorts of things. So there is just a ton of information that you're basically downloading from that satellite. And so anyway, yeah, go to this website here, and they do have some examples and everything on here. But when I first was developing this, I mean, there was very little other than this website right here. There was very little out there on the internet showing you how to use Tiny GPS. But I mean, this is a really great library, and so you might, I'm sure someone by now has probably created more information. There's probably YouTube videos on it. I mean, you could just spend an hour talking about Tiny GPS and all the things that it can do and everything. So, but like I say, I'm sure there's probably someone out there who has probably created a YouTube video or some websites or some other showing you all the possibilities with that. So anyway, go to their website, download that library, and install it. You'll install it pretty much the same way that you did with the HMC 5883L Compass library, pretty much the same way. And then the code here goes on down, and you can see I got it kind of sectioned off into different areas. You got the GPS, all the variables for setting up your GPS. You got your GPS course, and this number right here is a number of satellites that you're locked onto at any given time. And then we created an instance of the Tiny GPS. Um, and let's see here, we got our motor control board for the library there, setting up our motors, and we got our turn speed, which I was talking about in the previous video, talking about how our motors, we want them to go at one speed when it's turning, using our compass and our GPS to turn with, because we want to slow those motors down. We don't want to overshoot our heading. And then we got our other motor speed here that we're using for forward and reverse and left and right. And you can adjust this right here. You can change that. And if your car seems to be going too fast, if you want to slow it down, you can just slow that down to a number. I would say somewhere between, between 150 and 255 is where you want your numbers to be at. And then we got our compass, all of our variables to set up for our compass. And I go in here and kind of tell you the program, I've tried to document it as about as well as I could. So you'll see quite a bit of descriptions in all the code here, showing you what everything is. And so you got your desired heading. That's our heading that we want to be going in. We've got our compass heading. That's our actual heading that we're actually going in. And then we got our deviation. This is what I was talking about in the previous video. With our we can set our deviation to 5 degrees. So if we set our heading at say 180 degrees, then as long as our heading on our compass is somewhere between 175 and 185, then it'll just keep going in that forward motion until it's over that 5 degree mark. Now you can change this. You could make it lower, but as I was saying, you can. What's going to happen is the car, the robot, will just basically start shimmying back and forth and not really be going anywhere. If you set this too high, then of course you're gonna start veering way off course. So you want to keep it somewhere in this vicinity of 5 degrees. We've got our heading A and B. So in other words, our heading for our robot, if we're wanting to go, this is kind of the idea for cutting the grass or metal detecting. So if you're heading on your lawn, you're going in one direction, and you're turning around and coming back the opposite way, then that's to store the heading in one direction and the heading in the opposite direction. And this is this other number here is the pass to determine which pass it's on, whether we're heading away from us or coming back towards us. Next here we got our servo motor here. This is for the sweep here. So that's all it's controlling, just kind of a deal for the metal detecting arm, or whatever you call it. This is what I was basically using in the video with the actual metal detecting bot. This pretty much is the same code. It's very similar. Let's see, we got our ping sensor, which, like I say, this is more for testing purpose. I got it working at one time, but then I was having some issues with it, and so I kind of just pretty much dropped it. And it's really not one of these things that I really spend that much time on, so it's not a big factor for me. So use at your own discretion. Next, we got our Bluetooth variables, where we're receiving our string coming from the our phones, and let's see here, it stores the stores the last value that we receive from Bluetooth. You got another one right here, this pin 34. It's not really used in the code here or any of the stuff that I've showed you. If you happen to go back through and look at one of my videos, I think I talked about a idea that I had for in case the Bluetooth module, if we lost control of the vehicle, this would basically stop the car. And the idea that it worked on is if the one of the pins on the Bluetooth module, if it lost connection with the phone, then that pin would that is basically connected up to the blinking light that you see on the HC06 Bluetooth module. And if that light ever starts blinking, it basically sends a stop command to the robot to tell it to shut the motors off. So it was kind of a runaway robot thing. So if it lost Bluetooth connection, then it would just shut the motors down and keep the robot from running anything, which is no big deal with this little small robot. But if you have a really large robot, then, well, that could be a kind of a big deal. So anyway, that was my idea for trying to stop a runaway robot if we lost connection with Bluetooth. Let's see here, we got the GPS, all the GPS stuff right here, which is this is a variable for storing our distance to home. We need to know how far away we are from our next waypoint. So that's where that variable is stored at right there. We have an array counter, which, like I say, right now we only got it set up to store 5 waypoints. And then we got our latitude and longitude waypoints. This is the variables that it stores the latitude and longitude in, and our increment for our array counter. Let's see here. All right, this is the setup program. We got our serial communications that we use if we have our robot hooked up to our computer, so we can use the serial monitor here to see what's being displayed. Then we got our serial 1. This is our communications back to our Bluetooth to our cell phones. So this is what it sends and receives information from. For our cell phones here. Serial 2, this is hard serials. All these are hard serials right here. So our serial 2 is for our communications for our GPS module, our U-Blocks 6M GPS module. It's set at 9600 baud. 9600 baud is pretty much standard for most those GPS receivers. However, you could change that, but there's a lot involved in doing that. And I've actually done that in some instances, but I haven't really noticed any kind of big improvement. This is again the servo. No big deal. That's for the servo for the sweep arm. And then we got our ping sensor. Like I say, this is nothing. This is just almost testing kind of stuff. So I don't know that I'd really get too involved in all that. And this is again for our compass. Right here is the important part right here for our compass. This is where we're going to enter our offsets. If you remember in the video when we were talking about calibrating our compass, this is where we're going to enter our calibration numbers at. Those two numbers that I told you to write down onto the compass, and remember those. That is where we're going to set our X and Y offsets at. So this is, I think right now, the only portion of the code that you're going to need to change just for your robot. So make that change right there, and once you calibrate your compass, because that's going to make a really huge difference in how accurate your robot is. And then if you can see the void loop right here, this is very short bit of code right here. We got our Bluetooth portion right here, and what it's doing is it's just basically waiting to receive some information, a Bluetooth command from our cell phones. So it's constantly scanning to receive some information from our cell phone to know what to do next. We got our GPS. What this does is it's constantly getting information, updating our GPS location all the time, so it's making a quick loop of that. And also the same thing with the compass, getting our heading on a constant basis. We want our GPS information and our heading information to be as try to get that information as quickly as possible. We don't want any old data. We want it as quickly as we possibly can. If you'll notice in the code here, I've really limited. There's very few delays in the code. I've tried to limit those as much as possible. I also try to limit as much as possible any serial communications with our computer, because this slows our code down. We want our code to be as slick and as fast as possible for in order mainly to get our GPS information as quickly as we can, because we want to have the latest position for our robot. That'll really makes a huge difference. So if you're trying to change up the code, one thing I would tell you not to change up too much is don't put a bunch of delays in your code, because that will really mess things up. All right, and as you see these portions of the code up here, I kind of broke everything down into certain areas. So this is the main portion of the code, and then next we'll go to our Bluetooth right here. And as you can see, it's waiting to receive any string from our cell phone. And basically these things, if it receives a value of 1, when we press our forward button on our App Inventor app, what it does, it sends a digit 1 to our Arduino via the Bluetooth module, and it sends a forward. It actually runs a code here, forward here. You can see it says over here in steering. Let's see over here, and it just basically tells the motor, all 4 motors, to go forward at whatever speed we have set them at. And of course, at the time, our motor speed is at 250. And then the same thing with the reverse here. Of course, it's just going to send the code over here to reverse and tell all 4 motors to reverse, and so forth and so on. And then you got left and right. Of course, this is tank style steering. So you got your left turn and right turn, telling the motors to go in certain directions in order to turn left and right. You got stop car, which is send the steering over here and tell it to stop the car, release all 4 motors. We got our set waypoint, go to waypoint, turn around, goes back to steering, and right on down the line. I mean, these are all fairly straightforward. It should be fairly easy to understand what's going on when we press those buttons on our App Inventor app, and it's just sending these these numbers out over Bluetooth to our Bluetooth module, and then of course our Arduino takes that code and runs with it. This right here, the first one is the collision avoidance, which, like I say, this is dealing with the ping sensor, telling it to stop the car in case there's some object that's, I believe it's 12 inches in front of it. If it's, there it is. If it's within 12 inches, then it'll stop the car, and what it does, it actually sends crash to our cell phone, bring up the text in our little text box there on our cell phone, and it'll reverse the motors for a very short period of time, and then stop the car. And that's about all it does right here. You got a thing where you can toggle the collision avoidance on and off. So that's what that portion of the code is. Let's see, do an easy one here. Of course, we showed you this one here. We got our servo motor, which just sweeps that servo back and forth. And I found it is very important to put this attach and detach on here, because what I was having was, at least with the small robot car running with the L293, there was some like interference with the libraries between those, so I had to attach and detach the motor. So if you actually wind up using this for some reason, uh, this is very important to attach and detach if you're using the L293 motor controller at the same time, because there was some kind of a problem with the libraries interfering with each other. I don't really remember exactly what it was now because it's been so long ago, but just keep that in mind if you decide to use any of this portion of the code here. Let's see. That was the collision avoidance. We got our sweep, and let me go through this right here. We got our startup. When we first turn our car on, what you're going to see is on your screen on your cell phone, is you're going to see it say pause for startup, and it's going to just start counting down. It's going to count down for 5 seconds, and you can change that if you want to. And the reason why I did that was in case there was some reason there, say if I had something that I didn't have something that wired up once I turned it on, that the robot wouldn't malfunction and take off or do something like that. It gave me at least 5 seconds to kind of think about what I'm doing here and take care of any issues that could arise, and give me 5 seconds to do something about it. Like I say, you could change out, you could take it out altogether if you wanted to, but I would honestly, I would leave it in there just for the heck of it, because you just never know. You might have some issue where something's wired up, and you at least got 5 seconds to think about what you've done. And then what it does, it immediately starts searching for satellites in our code, and the get GPS. So it starts searching for those satellites, and what it's going to do is it's going to wait until you've got at least 4 satellites locked on, and then when it does get at least 4 satellites, it's going to tell you the number of satellites that are required and let you know that you've got a good lock on. Now you don't have to wait for the satellite lock on to start using it, because it's going to immediately start going back to waiting for a Bluetooth command, so you could drive the car and do whatever you want to. But until you get a GPS lock on, you won't be able to really use any of the GPS commands or anything, as far as going to a location, until you have a good lock on of at least four satellites. So that's the reason for that this portion of code here. Let's see here. We got our GPS and compass and go to waypoint. So well, let's go to steering here. All right, we got our forward 1 meter, which I really don't think I've used in the code here any. That was more for the for the one that using for the metal detecting robot. We got our reverse left turn, right turn, slow left turn, and slow right turn. That's the ones that I was telling you about. Reasoning behind that is because we don't want to overshoot our compass heading. Stop car, that should be easy enough to understand. And we got our compass turn right. So what it does is it turns the car 90 degrees to the right, and it does that. This was kind of a little bit of hard portion of code to write, but anyway, finally got that working right. And of course, this is compass turn left. That's just the basically the same code, just turning in the opposite direction. Compass forward, what that is where it actually steers and goes forward and uh, keeps the robot on a heading and keeps it within a certain deviation right here. So that's currently set at 5 degrees. So that's what this portion of the code does. It just maintains a whatever heading you set in, or heading you set on the compass. Once you click the compass drive button, that's what it does. It just drives the car forward and keeps it within 5 degrees of that heading. And if it veers off course, it slowly turns left or right, depending on which way it's inaccurate. You got the turn around. I don't think I talked about this in the previous video, but the turn around button, it just turns the car around 180 degrees. So you're just going in the opposite direction. And as long as you got your compass calibrated correctly, it should function right. So that's all of it for the steering right here. So that's the code for steering. And then got our other code here. This is for our waypoints. So once you press the go to waypoint after you've entered your waypoints, what this does, it just goes to the next waypoint. And so that's code for that. There you'll see some of this stuff has been commented out and things, whatever, but you can uncomment that if you like, so you can view some of it on your serial monitor. Although I don't really foresee that being a reason. I think some of the stuff that you'll see commented out, it was because I was doing testing and things like that, and so a lot of the code that's been commented out, you could probably just delete it if you wanted to, but I kind of left it in there in case someone wanted to be able to look on their serial monitor and see what's going on with the actual variables and such. Last, we have the calibrate compass stuff, which I told you this is very experimental, and I really haven't had that much luck with it. I mean, I really didn't get too involved in all that. So anyway, you can look at that, and if you want to develop that anymore, you can. We got our get GPS, which this basically just uses our excuse me, our tiny GPS library to get the latest GPS information, our current latitude and longitude. So every time this is called up, that's what it's doing, is it's actually getting our current latitude and longitude. This right here is our set waypoint stuff. Now, this is kind of some piece of code that I was working on, and it was just something that I just kind of put out there. I was actually just set up 2 waypoints, and I decided, well, go ahead and put in 5 waypoints. And really, what I need to do is just have this set up as make this code much more slick, and have it actually set up as a loop, where it's just you set as many waypoints as you would like into an array. But I just haven't had the time to sit down and work with any of this code lately. So anyway. That's something I probably need to do in the future, although I don't see it happening anytime in the near future. But it's something that I would like to work on, at least, and change that. But at least now at this point you can set up five waypoints, and you could just copy paste this code and make some minor changes to it and do that to have more waypoints if you'd like. Let's see. This is the one for clearing the waypoint, so you clear out the array. This is the code for getting the latest heading for our compass. So we're constantly trying to get our latest heading for our compass and for our GPS. This is our code for setting up our heading of our car. So when you press the heading button on the app, it set whatever direction the robot is pointed in. This sets that heading. It gets it, and what it does is actually taking several readings. So it actually takes five or six readings to get the latest bit of information from our compass instead of getting old data. So yeah, that's it right there. And then this is our GPS info button. When you press the GPS info button on the Arduino app, what it does, it shows you your GPS location and tells you the number of satellites and distance to home, so the distance you are away from your location. When you first start up the app, it actually tells it. See right, it actually sets the waypoint at the current location, because otherwise it's just going to give you some really crazy number, and you'll actually wind up being, instead of 5 meters from home, you would wind up being 5,000 or 10,000 meters from home. So anyway, let's see here. I think that's about it. I think we've covered most of all the major stuff. So yeah, there's your sweep, there's your steering, and got our startup, got our waypoints, and got our GPS and everything. And I think the most complicated part of this whole thing is probably our GPS information, is trying to keep it on a certain heading with our GPS. So these are the steering, and the GPS compass is probably the portion of the code that most people are going to be wanting the most, is looking at mainly this portion of the code right here. This is probably going to be the most important thing, because it's going to control the car, the steering left and right, and try to keep it at a certain heading, and then try to make sure that we're more than 0 meters from home. And of course, once we reach that 0 meter mark, our distance from home, then it basically stops the car and prints out that you have arrived, you've reached your destination. So this is probably the most critical portion of the whole code right here. So anyway, I'm going to try to wrap this up now, and what I would say is, if you have any questions or anything, try to post, put it on YouTube, and I'll see if I can answer them. This is, of course, as you know, I'm really into metal detecting, so with the temperatures warming up, I'm going to be spending a lot of time metal detecting and less time programming or anything. So if you want to post anything, I'd probably say, if you have any questions to post, I'd probably say post them Monday through Friday, and not so much on the weekends. But I'll try to get to them, and if I can answer them, maybe someone else that's watching the videos or on the Instructable website maybe they can answer your questions as well. Most of the things that I've run across with people asking questions on any Instructables, most of it has to do with wiring because they wired something up backward or didn't install one of the libraries. So make sure that you install these libraries. If you don't know how to install a library, there's plenty of videos on YouTube on how to install libraries. So and I even showed you how to install the library for the compass, and it works pretty much the same way for the tiny GPS. So if you have any issues with installing these libraries here, the motor shield library or the compass library or tiny GPS, just look on the internet or on YouTube, and I'm sure you can find plenty of videos on how to install libraries, because those will be very crucial if you're getting a bunch of errors, and that's most likely what the problem is right there, is because you didn't install a library correctly or it hasn't been installed at all. So definitely check that out if you're having any kind of compile errors. And also I make reference to it in the Instructable here. I actually did this right here on purpose. I actually installed two different libraries for the compass, and so if you have more than one library installed for the compass, you'll get an error similar to this right here. So if you're getting some kind of a compile error and it's saying that you've got more than one library installed, you probably need to uninstall your old library, and maybe move that to another directory or something there, or just delete it altogether. But if you're having a problem with the compass, if you've worked with compasses before and you've got another HMC 583L library installed already, then you'll definitely need to uninstall that and install the one that that we were talking about in the previous videos. All right. Okay, so I think that's about all that I can think of right now. I know this has been a very long video, but this is and I really haven't even gone over in a lot of detail everything that's going on here. But anyway, I think this should definitely get you started on the way, and then you can, like I say, what I would say is I would build this robot exactly the way that I build it. I mean, it's not very costly. I mean, I think you can probably build this robot for 50, maybe $60, and develop this. And I would go ahead and hook everything up the way that I've got everything hooked up. Go ahead and install the software and everything exactly the way it is. Don't make a bunch of changes to it or anything at first. Get it installed, get it hooked up, and then after you get everything working, then start making changes to it as you would like to, and then I think you'll see that everything works perfectly. So, like I say, if you have any questions or anything, just post them on YouTube, and thanks for watching.